Well, welcome back to our classroom series tonight. Our lesson is all about circles tonight. So one main thing you should know about a circle is that a circle has a center point right in the middle, and it has a distance from the center to the circumference called the radius. Again, the circumference is the distance around the circle, while the area is the section inside of the circle. So we're going to start with a little geometry review, maybe even Algebra 1 review, and then we're going to get into some nasty completing the square as we kind of near towards the end. So buckle up, it's going to be a good one tonight. So have you ever actually thought, what is a circle? What is the definition of a circle? Let's get into our notes. A circle is a collection of points that are a set distance, also known as the radius, away from a point called the center. Now, does that make sense to you? Let's just kind of sketch it out. It's a collection of points that are a set distance away from the center. So if I start with my center and I go out a certain distance, maybe 4, and I put a point, and then maybe I went 4 in this direction and put a point, 4 in this direction and put a point, 4 in this direction, etc. If I just keep doing this over and over and over, if those are all the same distance away, I should get a nice circle. So a collection of points that are a fixed distance away from the center. The circle below has a radius of 5 and a center point of 4, 2. So they're basically telling us this distance here, this radius is 5, and I know the center is 4, 2. Use the distance formula to show that 7, negative 2 must lie on the circle, and then verify graphically. Well, we should be pretty familiar with that distance formula. We've used it in class several times already. Remember, it's just the changes in y squared plus the changes in x squared. So here's a y and here's a y. So I'm going to say that's 2 minus negative 2 squared plus, now I'll do my x's, 4 minus 7 squared. Just clean that up. Those two make a positive, so I have 4 squared plus negative 3 squared gets me 16 plus 9, or the square root of 25, which is just 5. So you might be thinking, how did we just show that that point light on the circle? Well, they told us that the radius was 5, and we just found the distance of the radius between 4, 2 and this random point 7, negative 2, and we got 5. Therefore, we know it's on the circle. And now it says go ahead and verify graphically. So if I go over 7 and down 2, you should see that that point is on the circle. So we actually found this distance, which also turned out to be 5. And since the radius is 5, and that's a set distance of 5 away, we know we're on the circle. Part B says, now let's pick a random point on the circle. So it's the same picture, same idea as last time, but we're going to pick a random point, and instead of knowing the coordinates, we're going to call it xy. Write the distance formula for all points on the circle. So we know the center is 4, 2. We have the point xy, and it's the same problem from part A, so we actually know our radius is 5. And they want us to use the distance formula and write the equation. So again, I'll start with my formula. And I actually know the distance that I'm finding is 5. So I'm going to say I have x minus 4 squared plus y minus 2 squared. And I'm going to stop right there. That is actually the distance formula with everything I know in there. Now, the next part says square both sides of that equation to write the circle in standard form. So I'm going to rewrite this for myself. And again, when I square something, I'm basically going to wrap both sides up and square it. So I'm going to wrap this side up and square it, and wrap this side up and square it. Now on this one side, I'm going to get 25. And on this side, the best thing happens with a square and a square root, they zap each other out. And I'm getting x minus 4 squared plus y minus 2 squared. And notice, it's saying this should give you the equation of a circle. Does this look familiar to you? This is what the equation of a circle looks like. Has something squared with an x plus something squared with a y, and is equal to, let's just make a note here that this is our radius squared. Alright, so this next section is our formal definition, and we definitely want to get this boxed in. Okay, the equation of a circle whose center is HK and whose radius is R is given by, so this is a formula you should have memorized by now. You've probably spent a lot of time in geometry with it. X minus h squared plus y minus k squared equals r squared. And again, that HK is your center. It's the opposite of the numbers in there, and R is your radius. The one thing I always say to myself is that every section is squared. So the number sitting here is not actually the radius, it's the radius squared. So let's take a look at a few examples. Write the equation of a circle given the following criteria. So number 1, the center is 3, -1, or -3, -1, and the radius is 2. So I'm saying that's x minus h squared, so x plus 3 squared, plus y plus 1 squared equals, now remember you're saying radius squared, so if my radius is 2, I should actually put a 4 there. Why don't you pause it, try the next one, hopefully it's a piece of cake. Pause it. What do you think? Do you agree? X minus 4 squared plus y minus 7 squared equals 64. Again, I'm changing the signs of my center and putting the radius squared in. Now I've got x minus 4 squared plus y plus 2 squared. Remember, it's radius squared. So if I square this number, what nicely happens? That square and square root zap out, and I just get 3. Now I tried to make the last two a little more interesting. Yeah, we have the nice center, so x minus 12 squared plus y minus 2 squared. But now remember, I need radius and I need to square it. They didn't give me the radius, they gave me the area. So I've got to do a little scratch work off to the side. Do you remember the area of a circle? I always said apple pies r square was how I always remembered it. A equals pi r squared. And if the area is 25 pi, so I can put that in, is equal to pi r squared, basically my pi's cancel from each side. Radius squared is 25, so the radius is just 5. So now when I go to plug it in, I actually need radius squared, so I'm going to use 25. Perhaps you need to get that formula in your notebook if you don't have it memorized. You'll see it tomorrow. The next one I tried to get sneaky again. So center, piece of cake, x plus 2 squared plus y minus 4 squared. But again, I didn't give you the radius. This time I gave you the circumference, and it's hideous. It's 2 pi radical 7. So again, I need the circumference formula. Do you remember that one from geometry? Circumference equals pi times diameter. Now you'll remember, we don't really deal with the diameter in a circle. We deal with a radius. So I'm going to say, well, a diameter is just made up of 2 radii. So circumference equals 2 pi times r. Once I know that, I just need to plug in my circumference as 2 pi radical 7 equals 2 pi r. And again, watch how nice this is. The 2's cancel, the pi's cancel, and the radius is radical 7. So again, I don't want the radius, I want the radius squared. So if I square this, I get my radius squared is actually just equal to 7. Alright, so now we'll determine the center and the radius, given the equation. So I can't stress enough, it's x minus h squared. There's my center point, but I take the opposite, and just keep saying to yourself, it's equal to radius squared. So like I said, the center is usually the easy part. So I'm going to say this center is 2, 7, and then I'm going to stop, and I'm going to say radius squared is 100. So what is the radius? Square root. Radius is 10. I'll do another couple nice ones here. I would say my center is 5, -8, because I'm taking the opposite of that. Again, my radius squared is 4, so my radius is just 2. In C, you'll notice that they're not adding or subtracting any numbers. So there is a number that represents nothing, and that, of course, is 0. So this one's scheduled right at the origin. My radius squared is 121, therefore my radius is just 11. Alright, pause it and see if you can get the rest of them. Good luck. Pause it and check back. Alright, well I started the next three and I thought they were pretty simple until I got to F. Notice that my radius squared is 18. So to take my radius, I have to take the square root of both of those. Now you always want to simplify if you can, so I'm thinking 9 times 2, so I'm going to say my radius is just a little ugly and it's 3 radical 2. G hopefully adds 0, 0, radius is 8. I'm going to go 4, 2. Now here's another ugly one. The radius squared is 20, but I want the radius, so I've got to take the square root of both sides, so I'm going to say 4 times 5, or 2 radical 5. And last one, I'm going to say 0, 0, and my radius is the square root of 57. And that one can't get broken down. In the next section, we have to write the equations for the circles below. So again, all I say to myself is I need a center and a radius. And usually I have one of them but not the other. So let's take a look at the larger circle. Clearly I have the center, so negative 2, 4. All I need is a radius. Well, I can draw in the radius and say, okay, basically I need the distance between this point and this point. Easy enough. Use the distance formula and let's go get it. So I'm going to say change in y plus the change in x, 1 minus negative 2 squared. So that gives me 4 squared. That turns into a 3, so plus 3 squared. What is that? 16 plus 9. So I get the square root of 25, which of course is just 5. So that formula for my larger circle is going to be x plus 2 squared plus y minus 4 squared equals 5. Piece of cake. Alright, you've got the smaller circle. Again, don't cheat yourself. Pause it, try it on your own, and see what you get. So I worked through mine. I've got my center, my radius I got as a radical 13. So when I go to write that equation, I'm saying x minus 4 squared plus y minus 1 squared. Now remember, it's equal to radius squared. So if my radius is radical 13, I actually want radius squared. And when I square that, they zap out, and I just get 13. Alright, so we're nearing the end, and we're getting into the actual Algebra 2 part. Write the circle in center radius form by completing the square. Now, center radius form just means you can see the center and the radius. If I stare at this equation here, I have no idea what the center and radius is. So to do this, I complete the square. Now feel free to take any side notes off to the side that you may need to. I'm not going to list every step out. What I am going to make a note of, though, is that I always want to put the x's together and the y's together. So you can rearrange as needed. Okay, so make a little note. You can rearrange the order as needed, but you want the x's together and the y's together. So here we go. We're going to say x squared plus 8x plus a number minus a number plus y squared minus 6y plus a number minus a number equals 10. Okay, and that's how we complete the square. And we talked about that last week. So remember, we're going to take our b term. My b term is 8. I'm going to cut it in half or divide it by 2. I get 4. Wrap it up, square it. I should always get a positive number. In this case, I get 16. So I'm going to add 16 and subtract 16. Now the other thing I'm going to go back and do is I'm going to wrap those first 3 terms in parentheses. Now I'm going to do the same thing with my y value. I'm going to take that negative, or not negative b, I'm going to take my b value, which is negative 6, cut it in half. I get negative 3, wrap it up, square it, and I get 9. So I'm going to add 9 and subtract 9, but again I'm going to take the first 3 terms, wrap them up, because those are the ones that should factor nicely. Okay, so now I can say this is really x plus 4 times x plus 4, which of course is just x plus 4 squared. So can you see how we're developing that center radius? This 16 needs to get booted to the other side. So I'm going to add 16 here, and I'm going to add 16 here to move it over. So now it's gone. This side factors to y minus 3 and y minus 3. So notice there's a plus sign in between them. So plus y minus 3 squared. And again, this 9 needs to get booted over to the other side, so I'm going to add 9 and add 9. So when I add those, I get a total of 25. So let's just kind of box that in. I have now went from the standard form that's a little ugly to putting it in center radius form, which is really nice, especially for graphing. So I can clearly say that my center is -4, +3. My radius squared is 25, so my radius is 5. Now many times they're going to ask you to graph that afterwards, and they'll usually give you a grid. So obviously you go out to -4 and up 3, and you plot your point. But now you don't just make random points from this point forward. You plot at least 4 that you can do. You can count 5 up, down, left, and right. So I know 5 this way. Let's see, 5 this way. I can go 5 this way. I can go 5 this way. Then you can randomly connect them. But make sure you get at least those 4 main points in there. So you just saw a really nice version. This one's a little messier. So let's make another note. We'll definitely want to star this one. The coefficient of my x squared must be 1. Okay, so what if it's not? Again, make a note. We're just going to divide out the coefficient. So I notice right away. I know this x squared has to be a 1. So it has a 2 in front of it. It's simple. To get rid of it, you just divide every single term you see, even after the equal sign, by that number. So I'm going to divide everybody by 2. So that's going to get me x squared minus 4x plus y squared plus 3y minus 6 equals 0. Alright, so the first move, it's one extra step, no big deal. You're just going to divide everybody you see by that number. Now again, if you have to rearrange if the x's and y's are in opposite order, but you basically want the x squared next to the x, plus a blank minus that blank, plus the y squared plus the 3y, plus a blank minus the blank. And I'm going to shift that 6 over because I know I need it on the other side, so I'm going to add 6 to that side. Alright, and now it's just as easy as the last one. We're just going to complete the square twice. Take that b term, cut it in half, -2, square it. I'm going to add 4, subtract 4, and again wrap the first 3 terms up. Do the same thing here. I'm going to take 3, cut it in half. Oh no, it's not a pretty number, no big deal. I'm just going to leave it as 3/2 since I don't know what it is exactly. Wrap it up, square it. Square the top, I get 9. Square the bottom, I get 4. So I'm going to add 9/4 and subtract 9/4. No big deal, it's just a fraction. Wrap those first 3 terms up. Alright, so this should factor real nicely. X minus 2 and x minus 2. So I get the x minus 2 squared. Plus, let me show you a little trick. Take a look at this number. It's a -2. Where else did you see a -2 in this problem? Look at the number you squared. It happens every time. The number you squared is who your center is. So if this fraction freaks you out, just keep in mind, it's always the number you squared. If you're having issues factoring with a fraction, it's just the number you squared. +3/2 and +3/2. And how can you easily check? Well, when I distribute the last term, I get 9/4. In the middle, I get 3/2 plus 3/2, which is, 6/2, which is 3. So it's just always the number you square. So don't ever get too nervous about that. So +3/2. Now remember, I got to move these 2 terms over, so I'm going to add 4 to this side and this side. And I'm going to add my 9/4. So my 6 plus 4 is 10. So I'm just going to do a little scratch work down here. I actually have 10 plus 9/4. And get a common denominator. So I'm just going to basically, this is 10/1. I'm going to multiply the top and bottom by 4. So now I have 40/4 plus 9/4, which is just 49/4. So now you can see that my center is 2 comma -3 halves. My radius squared is 49/4, which is actually semi-nice because when you take its square root, they're all perfect squares, so my radius is just 7/2. Alright, well now we've hit a little bit of algebra, a little bit of geometry in our Algebra 2 section. So we'll get a lot of practice in class tomorrow, and have a great night.